Hello and welcome to Wabble, a case by Harry Watson for the MEWC 2024 round of 128 PM. Is it PM? Yeah, PM. So it's a text manipulation case. I brought in all my lambdas, and I will also do the so-called dim approach with pre-programming lambdas based on the case video, or in this case, me doing this case once before. So I use a lambda word in list and a lambda word to point. Word in list is lambda word is number x match word in this list here. Close all the brackets, and then word to points is lambda word x lookup mid word sequence then of word 1 in, so split a word into single pieces in here, returning this. Close the brackets. Now we save them. Find name word in list and also word to points. Well, in here. So now we can erase this and go further. So determine whether a string is word or not. So if word in list will handle true and false values, then yes, otherwise no. 40 points. Word to points will also work here for single characters, and for words it's sum minus minus word to points. And we can track this down and if this isn't a word, word in list, then we can do this, otherwise 0. Track this down and we are good to go. So for 3 levels solved, 260 points, easily scored when you have the opportunity and the ability and the luck to create lambdas after viewing the video. So now we have 2 points on this, and then multiply with if this equals dl, then 2, otherwise 1. Sum this up, and then multiply with count if, not if as count if, here VW, close the bracket, and bring this in here. Why is this wrong? It shouldn't be wrong. It's also the this is fine. I think this is again a problem. I hate this stuff. So I used is number x match dw in here plus 1, bracket around, and it's good to go. I don't know why countif is working here not properly. Never mind, we've solved this. And now let function s for string, st for start cell, t for direction, l for the length of the word, so s And now E for indirect board expression sign and SD. Now use offset. I is my start, no shift. And then if V equals down, then the offset is our height, otherwise it's our width. And then we get here such an array. We make this to a single row. And yes, T, not st, and then T, so if T equals DL, then 2 plus 1, multiply with word points from S, and then sum this up. And now, we need to use here something different, because we need to choose filter T if T equals W columns, if error, then 1, no, 0, plus 1 for 1. So if it's 0 plus 1, it equals 1 because 2 starts with 1. Then 1, otherwise 2, otherwise 4, otherwise 8. So because of 2 DWs, we get 8 here. Copy this in, shrink this down, and resolve this. So again, we want to place string on the board to the maximum score or possible directions. We need to go to board. First, I make this wrap around all ones, and then I use a lambda from dim, its distance to value, to get here the distance to the border. I drop the first row and the last row and the last column, make this a single column, and then to call address of range to get the addresses. I've shown this lambda multiple times before on my channel, so you need to watch my video to know how it works. So please watch my videos. That's good. So name those ranges ADR and ET for distance. Is this works? Yeah. So now we're going here. They're running, yes. We're going here and so I need this here. Now we want to map filter ADR if dt larger or equal to len of the word. Lambda-st, this is my starting cell. D we don't have anymore. So we're saying here 1. And then we use this here and the max function. And here we say 0. Close all that stuff. We're good to go for all the possible combinations. Wrap a max function around it. And we have our solution. Bring this in here. This is wrong. Yeah, of course. I need to adjust for the right thing, and now it's right. I can track this down. But there are a few errors. This needs to be a word from the list. G222. Otherwise 0. Yeah. Now we can drag this down and come to the solution. Level 7 should be very hard, but I have a lambda for this. Permutations, combinations. These are my letters. We to hand out all the combinations from those strings. And now we filter which are. So if you want to take a look at permutations, I think on both channels there's a video on it, over 1 hour. And this should be in the list. Yes. I hate when Excel is doing this. So we have 25 left, and we now need to map this. Not labs. Lambda a sum minus minus word to points a close. No, all that stuff. And we have here a solution. You can bring in here. And we need to wrap it in a max function. 36. Yeah. Now that we can track this down, we'll take a short period because the permutations calculations take some time. 8%. Also, my laptop is kind of super hot right now. Yeah, I hope it will survive. So all levels solved. Let's go to the bonuses. How many animals can you find in the strings level 1 to 6? Animals are given here. I use my bonus setup. This will lead to a lot of points in the MECC rounds, but I fixed this lambda. It is flawless, I hope it's flawless currently. Now search for this text in the first 6 levels here, and then is number, then we have there a match. We need to sum minus minus this up, drag it down, put a sum function at the bottom, and we come to 5, which is the solution. How many bonus spaces are the board? Count if this is the board here, and because every bonus is beginning with D, we use the asterisk to count them. 30. How many times does the most common letter appear in the words list? So I have a lambda for most of character in area, but it will face some problems after too much characters. So here it counts, but not for, I think, over 16,000 or so on. So I need to step into this and do something about it, but never mind. I don't think I have a large data set for it. No. So I use the old school approach. Len of this minus len of substitute in those text, substitute out the A to the alphabet horizontally against nothing, and we then have here fields where we count how often a character appears. We can then sum this up by column. Come to the solution. The max of this is 18,200 something. And also, if you don't have here the alphabet pre-programmed, you can use char sequence, 26 columns starting from 65. So I know this by heart because 65 is code of a large A. So then what is the total face value of all letters appearing in the case? back here, concat, I think we will not face the limit, and then sum minus minus word to point, and we have here our solution. Now, with all the bonuses, what is the highest score you can achieve by placing any word on the board? So it needs to be a word, and it needs to be from any game of level 7. Okay, so we need something like this, which we then put in this function here. Okay, let's do this. So we don't need this here because our words are from the list. We here have our permutations and then put in everything from the list with lambda w and put this in here where a word is. This should be fine, and we then need here a max function around this that this will not spill. It will calculate short amount of time, and we can track this down. It will calculate now a little bit longer. Hopefully it will not crash. Let's pray for Excel. This takes quite some time. Now it's calculating. 38. This is the last question. So this case is quite doable, I think. I don't know how many guys scored full points, but I think quite a few. 40% still running. 40%. So my laptop is also not the fastest, so with other hardware, it could be that you will be faster. So, and now our maximum is 168, which is, if it's calculating, also the, this takes ages. I should have gone to mini remote. Sorry for that. So it is the answer of all of this. Yeah, 1250 points. Thank you for your attention. As you saw, I have both 128 point rounds videos on my channel, and I hope to bring also the other videos on here in this week. So thank you for your attention. I hope to see you in the next one. Bye.